All computations in bases other than 10 are performed the exact same way as those in base 10. However, when a computation is equal to or exceeds the given base, we will use mental conversions to convert from the base 10 numeral to a numeral in the desired base. So we're going to be doing multiplication this time. So we're going to do 3, 4 base 5 times 3 base 5. So 3, 4 base 5 times 3 base 5. So we're going to treat the multiplication the exact same way we normally do. Just it's in different bases, so we just have to be careful of some things. So let's look at it. 3 times 4 is 12. Agreed. Now 5 or 12 exceeds 5. 5 can go into 12 two times with 2 left over. There we go. Now 3 times 3 is 9, plus 2 is 11. 5 can go into 11 two times with 1 left over. And then we can just bring the 2 down because there's nothing else. So 3, 4 base 5 times 3 base 5 is just 2, 1, 2 base 5. Again, 3 times 4 is 12. 5 can go into 12 two times with a remainder of 2. And then 3 times 3 is 9, plus 2 is 11. 5 can go into 11 two times with a remainder of 1. And then we just bring the 2 down, and that's the end. Let's look at this one. 2, 1 base 4 times 1, 2 base 4. So 2, 1 base 4 times 1, 2 base 4. So 2 times 1 is 2. 2 times 2 is 4. 4 can go into 4 one time with a remainder of 0, so 1, 0. And then we bring 0 down like we normally do in multiplication. And then 1 times 1 is 1. 1 times 2 is 2. And now we're going to do addition. And we do addition the exact same way we normally do addition with different base systems. So 0 times, or 0 plus, 2 plus 0 is 2. 0 plus 1 is 1. 1 plus 2 is 3. And we haven't exceeded anything, so we have our answer. 1, 2 base 4 times 1, 2, 1 base 4 times 1, 2 base 4 is 3, 1, 2 base 4. Now we're going to get into division. Now division can be a little bit squirrely, which is okay, because a lot of times you can use a reference table to make it a little bit easier. So we're going to do 2 base 4 divided into 100 base 4. So what I'm going to do is kind of write it over here. So 2 base 4, 100 base 4. So 2 can go into 10, or 10. So we look at the table and we see that 2 and 2 will give us 10 when we're doing base 4. So I can say 2, and then when I multiply it using this multiplication table, I can see I get 10, which will be 0. And then I have a 0, so 2 into 0, well, that's just going to be 0. And then 0 minus 0 is just 0, so I'm at the end. So 2 base 4 into 100 base 4 is 20 base 4. So this is our answer. Let's look at another one. Again, these are kind of odd. 4 base 5 divided into 134 base 5. So 4 base 5, 1, 3, 4, base 5. So 4 and 1, 3, so I'm using 4 and I'm going to see closest to 1, 3, which is actually 1, 3, so I can say 2, which will give me that. So I bring down the 4, and then I look to see in the table what can go into 4. Still at 4, so I go over there, I see 4, which is a 1, so 1. I get 4, subtract that, I get 0. That's the end of it. So 4 base 5 into 1, 3, 4 base 5 is going to be 21 base 5. This, again, is your answer. 21 base 5. Let's just do one more. Let's just make sure we feel okay with it. We're going to go back to base 4. We're going to do 3 base 4 divided into 2, 2, 2 base 4. So 3 base 4, 2, 2, 2 base 4. So 3 into 22, so 3, closest we're going to get is 21. So I'm going to use 3. Minus 21 is going to give me 1. Bring the 2 down. 3 into 12. So 3, 12 is right here, so it's a 2. And it's perfect. Gives me a 0 at the end. Nothing else I can do. I'm at the end of the number. So 3 base 4 into 2, 2, 2 base 4 is going to give me 3, 2 base 4. This, again, will be the answer for the division question. When you're doing division, especially in different bases, having the multiplication table off to the side makes life a lot easier. So you can see how it worked with base 5 and base 4. But again, it's a little bit squirrely, it's a little bit odd. Just take your time, and mistakes happen. Don't let that get to you. It's a weird thing to do. Just be patient and you'll make sense of it.